We discussed previously that a parabola is defined by the set of all points that are equal distance from both what we call the focus and then a line called the directrix. What we're going to look at today is how to write the equations of those parabolas in standard form. You guys have dealt with vertex form in previous classes where you had something like this and you had y equals x minus h squared plus k. These values helped you find the vertex, and then we plugged in additional values to find other points on the parabola. We're going to look at the standard form equation of a parabola, and there's two types of parabolas we're going to consider. We're going to have the vertical parabola, which is traditionally what you've dealt with up to this point, and you're going to have a horizontal parabola that goes in that direction. The general equations for those are, if you're dealing with a vertical parabola, the x term is squared and the y term is not. These other values, this still helps you find the vertex, the h value being the x coordinate of the vertex. And so this right here would be hk. This 4p is what helps us determine the directrix line, which in this case would be a y equals line, and the focus. And remember that this distance here between the directrix and the focus is going to be 2p. Likewise, if we look at a horizontal parabola, the general equation for horizontal parabola is going to have the y term is squared and the x term has the 4p in front of it. Notice that this vertex is still hk. They stay with their respective values, x and y. And again, that 4p helps us calculate both the line that's the directrix and the focus, but this distance is still 2p. We can use these equations to glean information to help us graph parabolas that are in standard form. Let's consider y plus 2 squared equal to 8 times x minus 4. We want to graph it and determine both the directrix and the focus. We can first determine the vertex, comes from these values, and our vertex is going to be 4, -2 in this case. We also know this is 4p, 4p equals 8, so p equals 2. From the information that we see here, we can recognize that since y is squared, this is going to be a horizontal parabola. And we can begin with the vertex. The vertex is going to be at 4, -2. And then p tells us how far up or to the right, in this case, since it's a horizontal parabola, and to the left to go. So we're going to go 2 in this direction, and this will give us our focus, and 2 in this direction to give us our directrix. Our directrix is going to be a vertical line at x equals 2, and our focus is going to be at 6, -2. We know that the distance here is going to be this 2p. So we have a distance here of 4, but we know from the definition of a parabola that a point has to be equal distance from both the focus and the directrix line. So if I go up 1, 2, 3, 4, that puts me at 6, +2, which puts me 1, 2, 3, 4 units from the directrix line. And then I can also go down 1, 2, 3, 4, which puts me at 6, -6, which puts me 4 units from the directrix as well. And that way I can find a total of 3 points in the parabola. As a second example, let's look at one that does not begin in standard form. So for example, if I have negative y squared plus 2x plus 2y plus 5 equals 0. First of all, I know that this is still going to be a horizontal parabola since it is a y squared term. And I'm going to have to use that complete the square method again. I'm going to get rid of this negative. So I'm going to end up with y squared minus 2x minus 2y minus 5 equals 0 by dividing everything by -1. And then when I bring my terms together, I have y squared minus 2y equals 2x plus 5. To complete the square, I divide this by 2 and then square it, which has me adding 1, which I must do to both sides. And then when I factor, I get y minus 1 squared equals 2x plus 6. Leaves me with y minus 1 squared equals 2 times x plus 3. This helps me find the vertex. Again, comes from these values, and the vertex is -3, 1. I also know that 4p is equal to 2, which results in p being 1/2. When I go to graph this, I'm going to go to -3, 1. And then I move p distance, which means it's going to move me 1/2 to get my focus and my directrix here. And then again, I know that this is a distance of 2p. So I also go up 2p, which puts me up 1 distance. That distance is in the y direction. So I'm still at -5/2 and up to 2. And then I also move down 1, which puts me at -5/2, 0. And I now have my 3 points, my focus, and my directrix.